Good afternoon, ma'am.
Yeah, good afternoon. Am I audible, Dhananjay?
Yes, ma'am, you are.
Okay, fine. Actually, I was waiting for you all. I don't know why rest of the students have not joined because our time is, I think I gave you by 2:40, and since last 10 minutes, I'm waiting for you all. Okay, no issues. Yes, I think yesterday we were learning about these molecules, the formation of molecules, right? I told you about the homoatomic and heteroatomic molecule, correct?
Yes,
Yes?
yes, ma'am.
Yeah. So homoatomic molecule means what? Homoatomic molecules are the molecules which are formed by the same atoms, right? Like hydrogen, H2 molecule, like oxygen, O2 molecule. And heteroatomic molecule, which is made up by these different atoms of, atoms of different element. Okay?
Okay.
Atoms of different element. The example is H2O and NH3. These are the basic example which you have learned earlier, right? Now we are going to go and learn few things about it. How do we have to form it? I think I have explained about the hydrogen and oxygen in last period. Yes?
Yes, ma'am.
Yeah. Water molecule and ammonia was remained that I'll explain, and we go for the Lewis structure. Yeah. Now here you can check the formation of NH3 molecule and the H2O molecule. We know that hydrogen atom has the atomic number 1, correct?
Yes,
Yeah. And then oxygen has atomic number 8, and again hydrogen has atomic number 1. If you see the structure of hydrogen, it has only one. Suppose this would be the nucleus, it has only one electron, right? For the oxygen, this is the nucleus we can consider. And here would be how many? 2 electrons in the inner shell, and the outer shell must be having how many? 6 electrons. 1, 2, 3, 4, 5, and 6. Similarly, here another hydrogen, it's a nucleus, and there would be 1 electron, correct? Yes? So while writing or while forming the structure, we are just considering this valence electron. We are just considering what this valence electron. We don't have to consider this inner orbital electrons. Okay, we are not going to consider it at all. Fine. Now what happened? The 1 electron from oxygen is being shared with the 1 electron of hydrogen, due to which what happened? These 2 electrons would be revolved around the hydrogen. Similarly, 1 electron from this hydrogen would be shared with the another hydrogen. This electron I'll erase from here and I'll write it here. Okay, so that would be convenient to understand. So these 2 electrons would be revolved around this hydrogen, and at the same time these 2 electrons would be revolved around this oxygen as well. So total electron around the oxygen would be what? 1, 2, 3, 4, 5, 6, 6 itself, and one electron would be shared by the hydrogen. So those two would be 8, right? So you can check it now. In this structure, this is a hydrogen. It shared its 1 electron here, right? This hydrogen shared 1 electron over here, and oxygen also shared one electron here and here with the hydrogen. So these 2 electrons will revolve around the hydrogen. These 2 electrons would be revolve around the hydrogen. So hydrogen's valency has been, sorry, a hydrogen duplet would be satisfied in the K shell. Okay. And in the oxygen, there would be what? 6 electron already in the outermost shell. By sharing a 1 electron by the hydrogen, it becomes 8 electron. And hence in the L shell of the oxygen, 8 electron would be completed. So it is also acquire inert gas configuration. Correct? Yes or no? So in this way, your H2O molecule would be formed.
Yes, ma'am.
Fine. In the same way, NH3 is also will be formed because nitrogen, if you see, its atomic number is 7, electronic configuration 2, 5. So how many electrons are there in the outermost shell? 5. Okay. Yes. How many electrons are lagged to complete its octet? 3 electrons are lagged, right? And those 3 electrons has been shared by what? 3 different hydrogens. Clear?
Yes.
Understanding?
Yes, ma'am.
Yes or no? Now
Yes,
see,
ma'am.
suppose this is a nitrogen. It's a nucleus of it. And it has how many electrons in the outermost shell? Only 5. So among that, 2 electrons would be here. 1, 2. Here 1, 2, 3. 5 electrons. Inner shell orbital I'm not going to consider. I told you earlier. Right. Now, when hydrogen would be nearby, this hydrogen would be shared its 1 electron with the nitrogen and complete its duplet. Correct?
Yes.
And now total number of electron around the nitrogen would be these two, 6, 7, and 8. So nitrogen would complete its octet. Among those, only 6 is utilized into the bonding, and this would be remain as it is vacant, and this called as what? Lone pair. This is what? Your nitrogen's lone pair. Clear?
Okay.
Fine. Now we'll move forward. Lewis representation we are going to see. We are going to look about what it is, Lewis representation. Check it now in this.
From what?
Lewis representation of a simple molecule, the Lewis structure, how do we have to write it? So first of all, what we have to do, the Lewis dot structure can be written through the following steps. In that, the first step is we have to calculate what? The total number of valence electron of the combining atoms. Whichever 2 atoms are combining with each other to form a molecule, their valence electron you have to calculate. Now each anion means addition of 1 electron and each cation means removal of 1 electron. This gives the total number of electrons to be distributed. Right? If each anion suggests what, there would be the addition of electron. Cation suggests what, they would be the removal of electron. And by knowing this, what you will get to know, it will give you the total number of electrons to be distributed. How many electrons you have to distribute. By knowing the chemical symbol of the combining atoms, you should be aware of the symbol of those atoms. After placing shared pairs of the electron for the single bond, means 1 pair of shared electrons need to be utilized for what? Single bond, right? The remaining electrons may account for either multiple bonds or as a lone pair, right? And it is to be noted that octet of each atom should be completed. What is essential? Octet of each atom should be completed, except what? Hydrogen. Helium is already completed its duplet, except hydrogen. Hydrogen must be complete what? Its duplet. Correct? Yes, Dhananjay?
Yes, ma'am.
Fine. Now see here they have given you HBr. How it will be formed? Bromine have how many electron in the outermost shell? How many? 7, right?
Yes.
1, 2, 3, 4, 5, 6, and 7. So 1 electron has been shared with hydrogen. So see this colored dot is given by the shared electrons, correct? Yes or no? So it will be your Lewis dot structure. Now next is what? 2 hydrogen when connect with sulfur. Sulfur has a 6 electron because sulfur belong to the oxygen group and oxygen and sulfur has the same number of atoms, same number of electron in the outermost shell. As oxygen has a 6 electron, sulfur also have a 6 electron in the outermost shell. So to satisfy sulfur, to complete its octet, there is a need of 2 electron, and that has been shared by these 2 hydrogen. You will get what? This structure. You can see around the sulfur, there would be what? 1, 2, 3, 4, 5, 6, 7, 8 electrons are there. So it will be complete the octet of sulfur and the duplet of hydrogen. Correct? Now, if we see the nitrogen bond, we know that there is what? How many? 5 electrons are there in the nitrogen in outermost shell. Okay. So what happened? These 1, 2, 3, 1, 2, 3 electrons have been shared. So how many pair of electrons? 3 pairs of electrons. 1 pair of electron would suggest what? Single bond. So 3 pair of electron would suggest how many bonds? 3 pair of electrons suggest how many bonds? Triple bond. And hence nitrogen has triple bond. Nitrogen molecule has a triple bond in that. Clear? Yeah? Yes?
ma'am. Can you explain the second, the Lewis structure one?
This
Second
one.
point.
This,
No, ma'am. Second point about.
this one. Each
Yes, ma'am.
anion means addition of 1 electron. Okay.
Yes.
And suppose chlorine get converted into Cl minus. What does happen in this? You have to add 1 electron. If sodium is being converted into Na plus, so what happened in this? Minus 1 electron. So this is the thing you need to keep it in your mind. So once you understand, you will get to know how many electrons you need to distribute. Correct?
Yes, ma'am.
Yeah, that is there. Nothing else. So simple.
Got it.
Fine. Shall we move forward?
Yes, ma'am.
We are going to know about the formal charge now. What is the formal charge? C? In polyatomic ions. Polyatomic ion means which consists the number of atoms more than 3. Okay. The net charge is the charge on the ion as a whole or not by the particular atom. However, charges can be assigned to individual atom or ions. These are called formal charges. See once again. In polyatomic ions, the net charge is the charge on the ion as a whole and not by the particular atom. However, charges can be assigned to the individual atoms or ions. These are called formal charges. Clear? So what is a formal charge? For example, PO4 minus 3, correct? This is what? Polyatomic ion, isn't it?
Yes, ma'am.
Yeah. So phosphorus has a certain charge. Oxygen has a certain charge. Tell me the charge on the phosphorus. Oxygen has how much? Tell me. This would be what? Minus 3. Total charge would be minus 3. One oxygen oxide ion has a minus 2 charge. So 4 to the minus 8. Okay. So how much need to be added over here? 5, right? So phosphorus has a 5 charge, right? Plus 5. So minus 8 and plus 5 would be minus 3. So overall charge is minus 3. So this minus 3 charge would not be of phosphorus and even not of the oxygen, correct? It is a net charge. What it is?
Net charge.
Net charge or total charge on the molecule. And it is not by the particular one atom. Okay?
Okay,
So
ma'am.
what they said, however, the charges can be assigned to individual atom or ions. These are called formal charges. And how you can calculate those formal charges? Here it is given. Please write down this. It's very important for you. That is what? Formal charge on an atom in a Lewis structure is equal to total number of valence electron in the free atom. Whichever atom would be free, its valence electron you have to calculate first. Minus total number of non-bonding or lone pair electrons. Minus 1/2 total number of bonding or shared electrons. Please write down this formula, which is very important. How you are going to calculate the formal charge? Total number of valence electron of free atom minus total number of non-bonding or the lone pair electrons. Okay, minus 1/2 total number of bonding or a shared electrons. Clear?
Ma'am, could you explain this formula with an example?
Sorry, I'm not able to hear you. Can you speak little louder?
Ma'am, could you explain this formula with an example, please?
Yes, that's what I'm gonna take. Wait a while. With example only we are going to solve. So first of all, you write down the formula so you'll understand. Okay?
Okay, ma'am.
Wrote.
Yes, ma'am, written.
Wrote this formula. Fine.
Yes.
Please. See now what is given about this. It does not indicate the real charge. Let us consider the ozone molecule. Example they have given for the ozone molecule. The Lewis structure of O3 may be drawn as this would be the ozone structure. Right? How it is, you can check. Oxygen, first oxygen has a 2 electrons. Right? Here would be double bond. Right? It has what here also 2 and 2 electrons. Total number of electrons on that oxygen is nothing but 4. And when you will see this oxygen, it has a 6 electrons on it. 1, 2, 3 pairs of electrons. So there are 3 atoms, 1, 2, and 3 atoms. Those who have a different valence electron around it. Okay. So the central atom O marked as a 1. Formal charge on that we have to calculate. Right? We know the valence electron in the oxygen is nothing but what? 6. Correct? Because what we know, oxygen atomic number is 8. Correct? So its electronic configuration is 2, 6. So valence electron is what? 6. Right?
Yes, ma'am.
Srinath. How much? 6. Correct?
Yes.
Fine. Now
Ma'am,
what is? Yeah. Yes, Shreyasi.
ma'am,
Lone pair. You have joined late. I know I have seen it.
yes, ma'am. My laptop was not turning on, ma'am, so I had to.
So are you there with me or not right now?
No, ma'am, I'm not getting it.
You're not getting.
Yes, ma'am.
Do one thing, at least this formal charge formula is there, na, that you write down, that box formula. If you solve 3 more example, 2, 3 more example, you'll understand exactly what I'm explaining. Okay?
Okay, ma'am. Yes, ma'am. 1 minute, ma'am.
Yeah, please write down that formula. So we are going to calculate the formal charge on the oxygen, this first oxygen, right? So how many lone pairs are present on this? 2. 2 electrons are there, right? Non-bonded electrons, how many? One lone pair consists how many electrons? 2 electrons. So that will be 6 minus 2. And another one is minus 1/2 pair bonded electron. How many bonded electrons are there? How many bonded electron you can see? 1, 2. Here is a double bond. Here is a single bond. One single bond consists what? 2 electrons. And double bond would consist what? 4 electrons. So here it will be 4 electron and here it will be 2 electron. So shared electrons are how many? 4 plus 2 is equal to 6. Correct? Yeah?
Yes, ma'am.
Yes or no? According to this formula. See, total number of valence electron of the free atom. Now suppose this is the free atom, oxygen. Its total number of valence electrons are how many? 6. Minus non-paired electrons or non-shared electrons. That is nothing but one lone pair electron. One lone pair is present on the oxygen. One lone pair consists 2 electron, minus 2. Minus 1/2 shared electron. How many shared electrons are there? 6. Because here is a 2 bond, double bond, and here it is 1 bond. One bond consists how many electrons? 2 electrons. So total it will be 6 electrons. Now, 2 3s are 6, correct? That will be 6 minus 2 minus 3. Right? Total 6 minus 5, which is equal to plus 1. So for formal charge on this atom is nothing but what? Plus 1. Clear? You can check it over here.
Yes. Yeah.
Yes?
Ma'am, I wrote it down. Ma'am, can you explain what formal charge is?
That's what I'm explaining. Wait. Dhananjay, have you understood?
Yes, sir. Yes, ma'am.
Can you calculate for the second and third atom till the time then second and third oxygen? I'll
Yes,
explain
ma'am.
her.
Yes, ma'am.
Okay? Fine. Please calculate. Fine. Shall I erase it all?
Yes, ma'am.
Shreyasi, shall I erase it all?
Yeah, yes.
Fine. Now see what is the formal charge. We know that in a polyatomic ion, the net charge is charged on the ion as a whole and not by the particular atom. Correct? Just now I have explained about the PO4 minus 3. So this minus 3 charge is not of phosphorus and even not of oxygen. Correct? This is a
Yes.
net charge because this is plus 5 minus 4 2 is 8 minus 8 total it is minus 3. Correct?
Yes, ma'am.
Yeah. So, however, charges can be assigned to the individual atom or ions. These are called formal charges. Means for that, suppose what would be the charge for phosphorus? What would be the charge for oxygen? That is what formal charge. Understand? And that there is a formula to calculate these charges. What is the formula to calculate these charges? This one. Formal charge of on an atom in a Lewis structure is equal to total number of valence electron in the free atom. Whichever atom's formal charge you are calculating, its number of valence electron you should know. Minus total number of non-bonding electrons. Now, non-bonding electron means what? Lone
The
pair.
lone pair.
One lone pair consists how many electrons?
2 electron.
2 electrons. Correct? And minus 1/2 total number of bonding or shared electrons. Now, bonding electron means what? Number of bonds you have to calculate. First of all, how many bonds are there on that with that atom? Okay. And one
Yes, ma'am.
bond consists how many?
2 electrons.
Electrons. Correct? So same we have done for the ozone molecule. Ozone molecule has how many oxygen atoms? 3 atoms. Here it is 1, 2, and 3. Correct. For the first number of oxygen atom, already we have seen oxygen atomic number 8. Its electronic configuration 2, 6. So valence electron how many?
6.
6. Okay. So I'm going to calculate the formal charge on the oxygen with number 1. Okay.
Okay, ma'am.
Formal charge, oxygen or O1. Like that I'll calculate. What you will
Okay.
get here? 6 minus. How many lone pairs are there on that?
2 lone pair.
Huh?
2 electron,
Lone pair
which
is 1.
are lone.
Lone pair is 1, which
Yeah.
consists of 2 electrons. So 6
Yes, ma'am.
minus 2. Correct? Yes?
Yes, ma'am.
Minus 1/2 into how much? Number
Total
of
6.
total number of bonding electrons. So you can check this oxygen is connected with this third oxygen with single bond. This one oxygen is connected to the second oxygen with double bond. So double bond is nothing but 2 bond. 2 into
Yeah.
2 electron. That is 4 electron of this side and 2 electron of this side. So total
So
shared.
total 6 electrons, which
Yeah.
are 3 pair.
Yes. So 2 ones are 2, 2 threes are 6. Correct? So 6
Yes.
minus 2 minus 3. That is 6 minus 5, which is equal to plus 1. So formal charge on that oxygen is plus 1. Clear?
Right, ma'am.
Understood? Hello?
Yes, ma'am.
Yeah. So have you calculated, can you calculate for the next 2 atoms?
Okay, ma'am.
Second and third oxygen. Already Dhananjay has been calculated. Very good, beta. Correct. Shall I erase it now? Yeah. Representation also.
Sir, I got it 0.
Sorry?
I got it 0 for the second oxygen
Correct answer you got. No,
on the
that?
left side. Yeah,
Yes,
yes.
that would be 0. Yeah. Now we are going to see the limitations of octet rule, correct? I hope both of you understand about the formal charges.
Yes, ma'am. Ma'am, once can you show the formula as well?
Yeah, sure.
Okay.
Here is the formula. Please write down.
Yeah, yes, ma'am. Done, ma'am.
This one. Done?
Yeah, it's done, ma'am.
Now we're going to see the limitations of octet rule. The first one is what? The incomplete octet of central atom in some covalent compound. Central atom has a less than 8 electrons. That is, it has an incomplete octet. Example is given LiCl, right? Then BeH2, right? Barium hydride, and then BCl3, right? So
Yes.
lithium, beryllium, and boron. See, lithium, beryllium, and boron, right? These molecules have electrons, respectively 1, 2, and 3 valence electrons only. Lithium has only 1 valence electron, beryllium has 2 valence electron, and boron has a 3 valence electron. Then they form a covalent bond with fluorine, hydrogen, and chlorine, respectively. Fluorine, hydrogen, and chlorine, respectively, right? So when they form the covalent bond, it does not complete its octet. This is a limitation. Means central atom does not complete its octet in many covalent compounds like lithium chloride, beryllium hydride, and boron chloride. Right. Now next, odd electron molecules. There are odd electron molecules. Another reason is what? Odd electron molecules. There are certain molecules which have an odd number of electrons. The octet rule is not applied for all the atoms. Right? For example, nitrogen, we know that its atomic number is 7. So if atomic number is 7, its number of electrons are also odd. Right?
Right,
So
ma'am.
octet rule will not be applicable for such kind of atoms. Okay. So here you can see 3 atoms or 3 electrons over here. Here are how many? 4. And how many are shared? 3. I see
One pair.
here you can check. Someone's cell phone is ringing or what?
No, ma'am.
Okay, fine. Now you can check over here. To complete, it may lose or gain 1 electron. Lone pair can be also utilized by the nitrogen because nitrogen has an odd number, 7. Correct? Now next, third
Ma'am,
example is,
I'm not understanding how does it like not complete its octet in the first one, ma'am?
sorry,
How did it not complete its octet in the first
central
examples?
atom, central. Lithium, you can check lithium. Atomic number is what for the lithium? 3.
3,
Electron configuration 2, 1.
1.
The outermost shell has how many electrons? 1 electron, right? Yes.
Yes, ma'am.
Cl require 1 electron, correct? Because its atomic number is 17, its electronic
17.
configuration 2, 8, 7, right? This would
Yes, ma'am.
this 1 electron has been shared with this. 1 electron would be shared by chlorine. So octet would be complete in chlorine, but then octet wouldn't be complete over here in lithium. Only duplet would be completed.
Okay,
Understand?
so it's about the octet and the duplet.
Yes,
Okay.
it's about the limitation of octet rule. Your second
Okay, right, ma'am.
atom, your metal does not complete the octet,
Right, right. Yes, ma'am.
right? Does not complete octet.
Octet.
Got it? The same thing for the beryllium and boron as well.
Yes, ma'am. Got it.
Yeah. And as we know that nitrogen has an odd number of electrons. So when there would be the odd number of electron in the molecule, that time what they said, octet rule is not applied to all the atoms. Yeah.
Yes, ma'am.
Keep it in your mind. At least 1 or 2 example you have to keep it in your mind. Whatever I gave that you have to learn. Fine. At least 2 example you should be aware of. And the next is given the expanded octet. Sometimes octet has been expanded more than 8. In many compound, there are more than 8 valence electron around the central atom. Here it was what? Lacking to complete octet, and here it is more than the octet, right? In the term of expanded octet, for example, phosphorus P F5, right? Phosphorus pentafluoride, right? You can check phosphorus have a 1, 2, 3, 4, 5 bonds. 5 twos are 10 electrons. How many it should be? It should be 8 electrons. So it is example of what? Expanded octet. Correct? SF6, right? In this, how many fluorines are there? 6 fluorine around the sulfur bonded with single bond. One single bond is consists 2 electrons. So total number of electrons, how many? 12. How many it should be essential? Only 8.
Only 8.
Yes. Here you can see the sulfur is bonded with doubly with oxygen. So here would be 4 electron. Here would be 4 electron. Total 8. And here how many? 2 electron.
2.
Here 2 electron. How many? 4 electrons. So
10.
4 and 4, 8 and 4, 12
12.
electrons.
Okay.
Sulfur. And hence it is also example of expanded octet. Okay.
Where
Right?
there is more number of electrons
Yeah,
than it's
more number at
necessary.
the center, that would be the expanded octet. When they would
Okay.
be less number than the 8, that would be what? Incomplete octet.
Okay, ma'am.
And odd number, odd electrons are present into the molecule. That time it does not follow the octet rule. Okay. So these 3 things you need to keep it in your mind. These are the limitations. Clear?
Yes, ma'am.
Fine. Dhananjay, understood?
Yes, no.
Fine. Now we will move forward. Other
Ma'am,
drawbacks.
can you like give us time to write this
Sorry,
once, ma'am? Can you give me time to write this down?
time for what?
To write these limitations.
I have to go back. Fine. You want to draw this? I'll share this in your resources, girl.
Ma'am, okay, fine, ma'am. Yes,
Yeah. Why? Because I don't want to waste your time. Already both of you have joined late.
ma'am. Okay, ma'am. Fine, ma'am. Ma'am, when the class starts at 2:45, ma'am, at what time does it get over?
2:45 to 3:30.
Acha. Okay.
What?
Yes, no, ma'am, no, ma'am.
You were not aware about it. This timetable has been framed for you specially, I guess.
Yeah, yes, ma'am. I wasn't aware that this was the like duration of it. I was
Don't miss
just knew it.
classes. See, Dhananjay, it's very important. If any point would be missed, you won't catch up it again. It will take a lot of time. You need to like, go through the recording and all. It's a tedious process. Better you attend the classes regularly on time. Clear?
Okay, ma'am. Yes, ma'am.
See what is given other drawbacks of the octet theory. In that, some noble gases also combine with the oxygen and a fluorine to form a number of compounds like XCF2, XCOF2, etc. Mostly what we say noble gases does not react, right?
Yes, ma'am.
Turn in your grade 10, I guess. But then, though it completed its octet, we have many compound which is formed by the noble gases like XCF2, XCOF2, right? So
Why
this
is that
is
so,
one of
ma'am?
the drawbacks.
Why do they still react?
You will come to know, beta, when you will learn about the molecular structure. That time you will understand. It's due to the excitation of the electrons.
Oh, okay.
Okay, ground excited state. That all things you will understand, and that time I'll explain you about the hybridization and all. Clear? So just now, what you have to keep it in your mind: drawbacks of octet theory. What is the drawback? Some noble gases, though they are noble gases, can form the compound with the fluorine. An example, XeF2 and XeO F2, right?
Yes.
This theory does not account for the shape of molecule. By octet theory, we won't understand the shape, which shape or in which shape a molecule is exist, whether it is tetrahedral, octahedral, triangular, planar, etc. That has been not explained by the octet theory, and it does not give any idea about the energy of molecule and relative stability, right? So these are the certain drawbacks of octet theory. Please note it down. It's quite important. What are the drawbacks? First of all, lack incomplete octet. Second, odd electron molecules does not follow the octet rule, and expanded octet. After that, noble gas, though they are noble gas, can form these several compounds like XeF2 and XeOF2. Then this theory does not give any sort of shape of the molecule or not explain shape of the molecule. And it does not give any sort of idea about the energy of molecule and relative stability of molecule. So these things you need to keep it in your mind. Now we are going to see few terms which are quite important for you. Bond length, bond angle, and bond order. Shall I erase it?
Yes, ma'am. Ma'am, you'll post this in resources, right, ma'am?
Sorry, yeah, I'll upload it in resources, don't worry.
Yeah, yes.
Yeah, it is defined as the equilibrium distance between the center of nuclei of two bonded atoms. Suppose A and B are the two bonded atoms and these are the centers of those atoms, right? So equilibrium distance between the center of the nuclei, centers of the nuclei of two bonded atoms, it is expressed in terms of A. Experimentally, it can be defined by X-ray diffraction or electron diffraction method. Experimentally, how we can explain it or define it? By the X-ray diffraction or electron diffraction method. And what it is exactly? It is defined as equilibrium distance between center of nuclei of two bonded atoms. Two bonded atoms. This is the equilibrium. This is the distance in between two centers, and its equilibrium distance you have to calculate. How you're going to calculate that equilibrium distance? The bond length in a covalent molecule AB R is equal to small ra plus small rb, where R is the bond length of Ra and Rb are the covalent radii of atom A and B respectively. Means this would be your Ra, this would be your Rb. Correct?
Yes, ma'am.
Yeah. Fine. Understood?